Hi, everybody. Can everybody see my screen?
Yes.
Okay. So I'm here to talk a little bit about the fabrication of PPE that we're doing both here and community-wide. Sorry, give me 1 second. Okay, so this is one of the statements that are driving what we're doing right now. Basically, the CDC gave a guideline saying if we don't have PPE to wear bandanas. And we felt that that was unacceptable and we have to find better solutions to that. So that's where we're at. Give you a quick timeline. On the 22nd, our Director of Imaging Services texted me about 3D printing masks, which he heard from his colleagues from previous institutions that he's worked at, that they are starting to look at these sort of extreme measures. We very rapidly prototyped one, and our process that we went through is we went and contacted immediately our infection prevention team. And then following that, we went to respiratory support and tested it with our respiratory support team. As you can see, in a course of 3 days, we then started sourcing into the community for 3D printing. And yes, and then following that, I've been essentially camping out here at Keck, trying to establish enough resources and enough 3D printed prototypes and masks ever since. This is a nice chart of my sleep patterns, if anybody cares. So what are we doing? So we're basically going and looking at what resources, non-traditional resources we can to make PPE. And our solution to this right now is creating a pseudo N95 mask. It's a 3D printed mask shell. We're using essentially off-the-shelf items that we can still obtain to create something that hopefully will pass the testing that we can give it. So that's a glamour shot that they took with when the reporters came. So we're basically making these hard masks. So right now we have about 50 of these completely built out and ready to be sterilized, and the filters put in and fitted for use. We currently have about 220 in the short time masks actually printed in the community. I want to give a shout out to 2 of the organizations that have greatly helped us. One is a maker group called Crash Space that has been sourcing their members and printing a great number of this. And the other is Sunweaver Creative, who we partnered with, and they've been invaluable with iterations of the design. So we basically got this model from a makerspace that is associated with MGH out in Boston. And we took this model and ran with it. We've also iterated this model. So we've actually created 2 models on the current branch for different sizes. As you can see, rigid masks aren't adaptable to different size heads and different size faces. So we actually have 2 models, one for larger faces and the other for more medium to, I guess, regular size faces. And we are getting more every day. We have synchronized drop-offs. We have a network of people that are basically collecting all the masks across LA and bringing them over here to Keck. On the Keck side, we are actually going to be streamlining the finishing construction aspects of this, applying the seal, applying the filters, and also, before applying the filters, the sanitation. So what we're doing for sanitation, which everybody's been asking, is we're following our infection prevention group's recommendations of using the hydrogen peroxide and then followed by UV sterilization. We've run some tests on the mask to see how it withstands these particular treatments. And after 5 cycles, it doesn't seem to have any effect on the materials that we're using for the mask. So we have some confidence that we are able to sanitize these masks fairly effectively. Let's see. I'll talk a little bit about face shields. I think Dr. Armani is going to talk a little bit more. No? Okay. We'll talk a little bit about face shields right now really quickly. So face shields are something that we can immediately deploy, but we have some design concerns. And since the face shields are designed to protect our frontline healthcare workers, these design concerns are actually major stumbling points that we have to overcome. Seth at the Dornside machine shop, I think he's on right now, Weeman, he gave us a design that has been very popular online, which is the Prusa model that has been printed out. As you notice, if you can see, the top of the Prusa model is actually open. And one of the issues with an open top is it basically prevents you from looking down, which a lot of our frontline workers might have to do, because that gives you a direction of possible infection. And also, the Prusa model itself doesn't cover all the way to the temples, so it leaves the eyes exposed from the side. And if a healthcare worker turns their head too quickly, they might be exposed. So our guidelines, and I'll talk about this in a second. So our next model that we have is a courtesy of Dennis Armani. His company, SMP Engineering, developed the second model, which actually is very useful. Dr. Armani has put this on the NIH 3D printing website. And for those of you that wants a personal one to use, this is a very good model. It covers the top. It's very lightweight. It's a large print, but it does cover all the bases that we're looking for. What we decided to do, though, is we standardized to the Budman version 3. This has the advantage of it has been certified already by NIH. Infection Prevention has tested it out, and they like the coverage. And finally, this is one that's also being sourced by Cedars-Sinai, as we found out through our crash space collaborators. They are already sourcing this. And so we're looking at mass production. If we're looking at mass production, we should try to get as much interoperability as possible. If there's already a source of these masks out there, we should be able to, if we're going to start generating face shields, to be interoperable with the face shields that are existing out there. So what we've done is we've standardized to this particular model. The most important part about these models is how is the face shield cut in terms of the hole placement stuff for the attachment points. If we have any future models coming out, they will be standardized to this particular hole spacing, so we can adapt whatever sheets that we cut to whatever visor we might need in the future. These models are currently being iterated for speed, essentially, less material, faster printing time. So as we get new models, we've been putting them out just to try to increase the print speed. To give you an idea of why this is important, take a look at the difference. It might look slight, but if you take a look at the picture on the left, notice that it stops shorter than the picture on the right, and that slight difference actually was very pronounced on a lot of our larger head testees, and the side coverage is very, very important. Now, one of the things that we also want to point out is that everything that is currently being made or has been made will be used. Nothing is going to be going to waste. So all the previous models, the iterations that we're using, they will be used. And we are looking very much forward to trying to standardize in the future, but that does not mean we are not using all the things that we have iterated in the past. I believe I'm going to lead into Tucker's talk. I'm just going to show you a really quick picture. I believe you've already delivered to us close to 300 masks for the temporary variety, and as Kim has pointed out, is already being deployed. And I want to talk really briefly about what my design philosophy of this for the masks are in terms of the N95 masks. Basically, I'm approaching this as wartime medicine. I'm looking at this as the guidelines have told us to wrap pieces of cloth around our face or put a sock in our face as our protection methods if we run out. And I want to stress that all of this preparation in terms of the masks are in case we run out. And they're not trying to supplant the certified equipment. It is all in case we run out. So this is all worst case scenario situation for the equipment that I'm building with the N95s. And that's been guiding my design philosophy in that I am not as worried about trying to meet certifications on a normal operating level. I'm trying to meet a very simple goal, which is provide better than a bandana. And with that, I'm done with my presentation.
Fantastic. So our first question is coming from Vidya.
I actually had, hi, this is Vidya. I work for GE Research, and I got this link and thought I would call in. It's interesting. I had a question about a follow-up question to the sterilization. So I'm not sure if it was it was a follow-up to a comment from I think Dr. Nanda and Dr. Borak, and I think it's relevant to Darryl's presentation as well. Is for masks that are being sterilized, I understand that you look for, you validate the sterilization techniques by looking at virus infection removal by a protocol. But what about if you're going to sterilize masks, N95 masks? What about the possible? Has the efficacy of the sterilized mask? How is that being validated?
Vidya, is your question that does it have the same filtration
correct
ability?
Yes.
Right?
Yes.
Yeah, so these are questions.
That's a critical question, isn't it?
Yeah, exactly. So a couple of things that I'm looking for. I don't think we really have the luxury of time before we proactively deploy this, but in an ideal situation, things that you want to make sure that our masks, which are the most important PPE, have is they have the integrity. We haven't compromised on that, and a piece of that is the filtration capacity, right? And the second piece is if we are going to reuse the approved N95 masks that are not the ones we've manufactured, we want to be able to look at those masks. How well are we decontaminating it?
So I was actually
another open question that you bring up, and it's a very valid question. And I'd love to work with someone to identify how we can get quantitative data and have confidence in what we are doing.
So Dr. Nanda, my original question had to do with the commercial N95, the certified N95 masks, because I have heard that they're being decontaminated and reused. Perhaps, and I will get in touch with you offline. But for the kinds of masks that Darryl described, it sounded like the filter piece of that mask would be potentially disposable, but maybe I misunderstood. And it seems like then that would be easier to, if there's a mask where the shell that holds the mask to your face can be decontaminated easily, because that's not the filter piece. The filter piece can be tossed after every use. Then maybe in that case, the decontamination is less of an issue. But for the N95, it seems like the validation of a decontaminated mask's efficacy should be
Yeah,
looking.
Vidya, I'd like to talk to you more. There are a couple of other things
Sure.
in the interest of time. I don't want to bring
Yeah.
those up, including shadow effect that comes into play
Yeah.
with 95.
Yeah.
Let's talk more.
Absolutely. Thank you.
Yeah, you are absolutely right. Actually, we are planning on just tossing the filtering aspect of these particular masks that we're making.
Yeah.
Black doesn't seem to work very well. But what is so essentially, if we get large rolls of N95 material,
Yeah.
you know, we could potentially save a lot of material using this method. Because this material, basically, we only need like a 2-inch square of fabric to do the filtering, as opposed to an entire large swath for the cloth masks that are currently being used. And you're right, we're wiping down and UVing the rigid component.
Shell.
Yeah, the shell. One other large benefit of this particular model is that we have a grill in front. I'm going to turn off this entire virtual background because, okay. We have a grill in front, and that actually prevents you from actually touching the filter, which is a problem with the cloth mask, because if you take on and off your cloth mask, you will eventually touch the mask. This actually prevents the filter actually from contacting a lot of surfaces. So we have some hope in this design. And this is not a new idea. I mean, you know, 3M sells respirators with N95 inserts. It's just a matter of quantity and being able to get it. Plus, in traditional settings in the hospital, you're not going to have, you know, hundreds of these type of cup interfaces, because sterilization normally would be too long to go through and wipe down each of these. But in a disaster situation, these are kind of invaluable in that the fact that they can be reused very quickly, even with the sterilization. So,
Thank you.
again, I just want to stress that all our N95 or pseudo N95 masks are in case we run out of all other protection devices.
Darryl, I don't know if you added that we actually did fit check this mask, and it
Yes.
did.
Oh, okay. Yes, I do want to point that out. So we did do a fit test, which is mandated, I believe, for every person using N95 to do every year. For those of you, especially in engineering and architecture, that don't know what this fit test is, you basically have to put on a mask. They put you under a hood and they spray a chemical, and you breathe. If you can taste that chemical, it means that the mask fit. Generally, for the mask fit, it means that there's a leak somewhere. For our case, we're testing two things. We're testing fit and if the filtering material will filter out that level of particulate. It's a rough test in terms of you know, quantitative numbers. There are none. It's a qualitative test. But it is a standard test that they normally do inside the hospital to check for fit on N95. And so we've done that on several of our iterations of the mask, and they've all passed. But again, it's very subjective to whether or not the mask itself will fit on the person wearing it. But it seems that our filtering material that we've chosen, which is a Hepa filter that can be sourced commercially, seems to be working on par with our N95 filtration from this test.
It's the same test with the same challenges we have with the traditional N95s, with the same, I'm assuming, going to be rate of failure for the face fit, except that I think that these 3D printed masks are a better fit in general, with a better seal in general.
Darryl, we're going to need to move on to the next speaker, if that's okay with everyone. Thank you so much. So let's move to Neha. Dr. Nanda.
Thank you, Tiffany. I sent SK a picture. I wonder if you could just project that for the group of the swab.
Yes, I can do that for you.
Okay, thank you. So what I'm going to do is I'll share with you what my request here is, and I want to get a sense if if that's feasible or we can engineer that product. So as you may know, that the two things that are key for us to overcome or even ride through the surge, or even in a non-surge setup, is going to be testing and personal protective equipment. And we'll be talking more about personal protective equipment, but testing is very key. And the reason is that if I get a test back in time, I can actually reduce the amount of PPE I need. So testing is very important. At this time at Keck, we have the ability to test several patients. However, where we are lacking today, and that's our bottleneck, is the swab that we need to use to put it on the machine to test if that virus is in that patient. So let me just walk you through how we evaluate a patient. So when there's a patient and we suspect that he has COVID-19, the first thing I have to do is I have to take a swab. So this is the swab that I'm going to use to put it in the patient who I'm evaluating, and kind of then roll it in the nose. I'm trying to get a nasopharyngeal swab. And then I take this swab, I put it in a vial. That vial either has saline or some media. Let's not get into the technicality of it. And that goes to the lab. In the lab, they take this swab and they isolate the DNA from it, and then they run it on the machine. And the machine is then going to tell us if the viral DNA is present in the swab or not. So you can see how having a swab is very, very important to be able to access tests, thereby being good stewards around using PPE. And at Keck today, we have the capacity to do around 200 tests, if not more, but the number of kits that we have with the swab, they are only 1,200, okay? And if we can design a swab like this, that would be great. I can send people specific catalog numbers of the most optimal swabs that we want to use in these patients, because it's not only having I'm sorry, Mia, I'm in the middle of something.
This is the first one.
Okay. I'm sorry, Mia, I'm presenting. Okay, sorry. What was that? Mia, 2 minutes, I promise. Thank you. So the swab, the swab is key, and that can help us a lot. The technicality of the swab is that it has to be a synthetic fiber with plastic shaft. We should not be using calcium alginate swabs or swabs with wooden shafts because that can inactivate the virus. That is really it. And yesterday night, I believe I sent SK a lab URL, the Forms Lab, where they actually have a 3D printer where they can do this. So I was just wondering, how can we start on a project with you guys so we can have an influx of these swabs and we can get the ball rolling in patient care and also being stewards around PPE. The ask would be about 5,000 swabs when possible. That's about what I have, Tiffany.
Dr. Nanda, this is Darryl. We actually are purchasing a Forms Lab 3D printer, specifically their medical grade, dental medical grade Form 3B right now. They're issuing the PO today. If they have a model that we can print those for you coming this week. I don't know what their entire setup is for this, but Form Labs, their 3D printers are resin-based printers, and we are getting one. So if we can arrange for a meeting afterwards and see what Form Labs is doing, we can probably, if it's using the same printer, replicate that. So just as a heads up on what we can do with that.
So
Thank
we
you,
also
Darryl.
have a printer
printer at Center for Advanced Manufacturing, and Mithul just texted, he has 2 Formlab printer in his lab. So we have access to about 3 printers right now. So we can call Formlab people and get their design and see how we can help you.
That would be wonderful, SK, because this is really going to change the face of what's happening.
Great. So we have now quite a bit of time. So Tiffany, we can just take questions, and perhaps the next speaker can go on at 10:20. So we have about 30
Fantastic.
minutes or so for questions. So now.
Perfect. So we have our first question from Sean Chapman. Sean had a question about specifications of the swabs you like and the sort of quantity you need.
I did, but Neha, it looks like you have already answered it for me. You guys need about 5,000 quantity that you're looking for, and the synthetic bristles and the synthetic swab tips. Something like this would be ideal for like mold injection technique. This is something that can be cranked out really quickly at that quantity very cheaply. So, but I'll take that offline.
So I think the other thing, Sean, I should mention is, because when you put it inside the person's nose, it should be something that is flexible and doesn't break, because then you're dealing with another problem.
Do you have an idea of like what sort of short hardness you're looking at from scale? Say something along the lines of maybe a short 20D or something like that?
I cannot answer that question. I can give you the product and I'll let you assess that.
That'd be perfect. And we can talk with Darryl about that as well.
Fantastic.
Okay.
All right. Vidya, did you have a question about the swab material and what makes it unique?
Yeah, I'm just curious if someone knows what's particular about it.
So Vidya, I don't know all the particulars. What I do know is there are other swabs that are available, and they have, it's the kind of material that it's wrapped with. It's polyester versus cotton.
Okay.
And cotton is not recommended, and it's polyester that's recommended.
Okay. And you will be sharing part numbers.
Yes. I'll send the catalog numbers, and I'm sure you have a keener eye for those things. Yes.
Thank you.
Fantastic. Frank Menjivar, did you have a question or just a comment?
Yeah, it was just regarding so when Darryl was talking, he was talking about I saw it on the chats that HEPA filters were being used. And I mean, I've kind of just been reading up on it because I've been curious about that for people that are printing this stuff and trying to use it. My concern is my understanding is that HEPA filters have fiberglass in them, and obviously that would cause a concern if you're breathing that material with fiberglass in.
Got it. Okay.
We're taking a look at it. We're taking a look at that. The filters we're using aren't I mean, they're commercially available filters, but I chose this filter because it's easily disassemblable. And when I took it apart, it's more or less stays intact. There's no need to peel off layers like a furnace filter. When cutting it and dealing with it and testing, I didn't notice any fibers coming off of it at all. It wasn't. So generally, fiberglass material will create little shards, and that's what we worry about. We've seen none of that creation. There's no dust that gets created when we're cutting this. And when touching the material, it actually isn't causing any kind of itch, which I normally associate with having small fiberglass shards coming out. I don't have anything better than that right now, except for the fact that just from a material handling standpoint, I haven't noticed any effects on this particular type of HEPA filter. And I do know that certain HEPA filters are more rigid and are set to be more permanent. This appears to be much more of a fabric kind of material. So less chance of the fiberglass. Plus, it doesn't crunch. So in terms of when I'm manipulating it, I don't know if that is the best answer, but it's what I have right now for this particular solution. I also want to mention that I am testing out this surgical wrap material that people have been posting about. This was it Hylon H600. The problem that we've come up with so far is that it's actually too good of a filtering material in that you can't really breathe through it quite easily on the small patch that we're looking for. So we might issue that for people with really good lungs that want to train for triathlons and are okay with a little bit of oxygen restriction.
All right, we have another question coming in from Victor Ong about synthetic materials.
Hi, yeah. My lab is starting up and we're starting to work with electrospinning fibers. But it was mentioned that sort of the swabs needed to have or be made of synthetic fibers. And I was wondering specifically why synthetic fibers. And in that case, if something like PLA, which is a biocompatible material, could be used to electrospin in fair quantities, such fibers that have water wicking capacities and storage capacities for sampling.
So Victor, I'll try and answer that question. As I understand, CDC and CLSI and the lab world always recommends a synthetic fiber because with that fiber, so let me take a step back. The test is only as good as the sample. If the sample has a good inoculum of the cells from our nose, then our test has a higher accuracy. And it's believed that with the synthetic fiber, the inoculum or the cells that you actually get from your sample site is maximum. That's the reason.
Okay. Do you know, I guess sort of, or does anyone else know what kind of fibers are being used now? Is there an issue when we're creating these things? We can 3D print the actual filaments to make them flexible and rigid enough to actually reach into the nostrils to grab the samples. But in terms of the actual sample collection site, is that a different material? What kind of materials are used, and have there been alternatives looked at for if we're looking to fabricate them on sort of a more distributed scale using machines such as electrospinning machines that are capable of producing fibers pretty quickly?
I think some of your questions, Victor, may be answered when I send the catalog numbers of the optimal fibers, of the optimal swabs that we would want. I don't want to speak beyond my expertise at all because I do not know. This is what we are always taught. Go with a synthetic fiber, and I don't know any more than that.
Okay, thank you. I'll look forward to that list.
Okay, I think we have just a few more minutes. Rob, did you have a question about the geometry of the file?
Yes, I was wondering if we had any files that were already readily available for some of these swabs so we can begin experimenting with some ways of printing it.
Do you mean any files? I'm sorry.
Oh, sorry. I mean like 3D geometry files for us to use in the printing of the part, or possibly designing injection mold systems around it.
So
something we can work off of.
Lab on the URL has perhaps what you're looking for.
Oh, okay.
So in the chats, I just plotted, or I posted a link to the Form Lab Test Swabs website.
Okay, great. Thanks for that.
Yep.
Yeah, and Rob, you'll also reach out to Formlab and try to see, what are their thoughts. And if they have some other thoughts, we'll try to collect that as well.
Will do. Thanks.
Okay. We have another question coming in from Dr. Barak. Zaya?
No, I didn't have another question. That was from before.
Oh, that's from before. Okay, let me take your hand down. Okay. I think we've answered all questions for Dr. Nanda. Can you please unmute and directly ask your question if we have not answered your question yet?
Yeah, if there were more questions for Darryl, when we had to at that time, kind of because of Neha had to go, so we had to kind of cut that discussion short. So maybe if there are any question for Darryl, we can field them right now.
So this is Vidya again. I think it may be a follow-up to a discussion about the filters that Darryl was using. I thought somebody asked if there was a possibility of silica in the filter material and potentially something that might not be good to inhale. Was that a question or did I misunderstand that discussion?
Yeah, I believe the question was about fiberglass being used as a material.
Right. So
yes, and right
sort
now,
that out fairly quickly by maybe whatever your filter material is. You could just have a cross section done at a USC materials characterization lab and check to see what's in it. A quick, it wouldn't take very long. Somebody'd prep a section and they could figure out what's in it structurally and chemically.
that's a great idea. If you can send me who I need to contact or who
You have to ask SK. I'm not a USC person, but.
I think the assumption you're making is that USC labs are currently up and running, and USC labs.
I'm sorry.
Yeah,
Yeah.
USC.
Okay,
yeah,
I may be able to help. Let me find out.
Yeah, I was going to say
Okay.
SC labs, like most academic labs nationwide,
Sure. Thank you.
shut down. Also, the question about the material choice. So there was an article in PLOS One, which is open access, and I put a link. So I think the selection of the swab material really has to do with the efficacy of the virus or bacteria or whatever release. And so that's why the specific material is chosen.
Okay.
So if you have another material, it might work, but the material that they're made out of now is known to work. So, but I posted a link where they looked at several other materials and compared the efficacy of sample release in swabs.
SK, I think if there are no further questions, we can move on to Tucker's presentation.
Yes, if there are no further questions, then we can move to Tucker's presentation. We can give people 1 minute to see if there's any other question that people want to ask. And I want to definitely 10:20 get going with Tucker's presentation.
All right, last call. If you have any questions, unmute and let us know now.
I just posted something real quick. Is there an amount of time that if you had an N95 mask that was exposed to the virus, that if you let it sit in a clean environment, will the virus eventually die and then make the mask reusable at that point?
Yeah, there are guidance documents that guide the reuse of masks that are not going through a formal sterilization process. And in general, they recommend materials that are drying, like cardboard, as the surface for setting them on. They also give guidance for avoiding things like direct UV exposure, so sunlight, you can't leave them there. And some hospitals actually are using processes like that already, where they cycle masks through a third or fourth day. So stack them at home, 1, 2, 3, 4, and then they start cycling on the 4th day. But there are some guidance documents about that question.
Okay, and I heard that somebody had mentioned maybe shooting it with a blow dryer to heat it up. Does that speed up the process?
I don't know about any recommendations regarding that.
Okay.
So I wanted to comment. I've also heard about people throwing it in the oven and baking it essentially. I don't know if I think right now it's a lot of theory being thrown around, and then they're using it in practice. But I don't know if there's any good science behind it right now. We are trying to reuse a piece of equipment that was never designed to be reused, and things like whether the elastic starts degrading, whether the material is, other materials that are not actually part of the filtering material are breaking down. For example, the nose bridge and seal areas from all these different methods. Groups are posting online what they're doing, but I don't know if any of it's been truly validated by anybody. I think Dr. Nanda could probably talk a little bit more about that. But we've seen a lot of people post anecdotal procedures of what they're doing locally. One word of caution is that we found that even places that are considered reputable academic centers, in their hurry to publish as much information as to what they're doing, might be putting out things that are not actually approved, and if you dig deeper, might be not supported by all the evidence out there. So maybe if Dr. Armani or Dr. Nanda could comment a little bit about that, maybe we can see what things we shouldn't be doing as might be a better thing than trying to figure out the best way, just to debunk some of the myths out there.
Yeah, Darryl, I'm not sure if Dr. Nanda's on anymore, but there are new guidances that just came out recently in the last couple days from the CDC that we are reviewing. So just so you know that.
Sorry, I just have one other final comment. So I don't know if anybody in this group actively monitors the ABSA listserv. So it's the American Biological Safety Association. So it's a group of all of the biosafety officers, both in clinical and research communities. So there's a listserv in which all these communities and institutions and universities are referencing the evidence studies that they are doing for the N95 decontaminations. And so one of the recent ones that's coming out of Stanford is the 70 degrees hot air for 30 minutes and the hot water vapor for 10 minutes, and how people are looking into converting catering services to reach those needs, and to be able to kind of take those types of, especially at universities, those large catering services, and to be able to modify them. But I would say the ABSA listserv is another great resource to be able to ask people who have been doing these sorts of evaluations for decades if people aren't aware of that.